can we go for our lecture? Actually, this is about chapter 3. Okay, chapter 3 is about moment. It is the additional of action of our force. Okay, so this from previous from chapter 1 and chapter 2 we have studied about our forces, okay, and then how to calculate how to break our force into fx and fy using our theta, and then we need to sum up our x and y direction of force, and then we can calculate our resultant force. Finally, we can calculate our theta. Okay. So nanti I will upload the tutorial, for question number 5. And mana tu? Okay. I will upload the tutorial discussion for the second part, and then I will separate our chapter 3. Okay. All right. Okay, this is chapter 3 is about force system resultants, and the content is about moment of force about specified axis, moment of a couple, so we have a couple moment, equivalent system, resultant of a force, and couple system. So mostly we want to discuss about our moment. Okay, moment is actually we have our force acting far away from our point. So the force that far away from our point have a distance. So the moment is the force that act far away from our point of action. So that is moment. Moment of a force. Scalar formulation. Okay. So today you will learn about moment, and I hope that you can understand and define moment. Determine moments of a force in 2D. I'm not sure if there are 3D cases in this cover in your chapter. Okay. What is the moment of the force 10 Newton? What is the moment of the 10 Newton force about point A? So our point of action is at A. That is our point of action. Okay, our point of action is at A. This is our point of action. We name it as A, and we have a force far away from our point of action, and we have distance from our point to the point of forces. Okay, so we have the distance, and the distance is 3 meters. So the moment is the force times the distance. So the unit should be Newton and meter. Okay, moment is equals to F times T. And remember, please remember that to get your moment, you need it to be 90 degrees. Moment and torque. Yeah, it is from force and also about the distance. Okay, so we have the application. What is the net effect of the two forces on the wheel? Okay, so we have our force, we have our distance. Okay, so we have force, this is couple. What is the net effect? What is the effect of the 30 Newton force on the lug nut? Okay, this is what we call lug nut. Okay, so we have force, okay, and then we have nut. So how do we calculate the force? Do we need to separate it into x and y direction or else? Okay, so from the first one, this is the quiz. I always remind my students to remember this one. This is very important. It must be perpendicular. So this is your point, this is your force, this is your force, this is your force. Okay? So you need to make sure that all the forces that act, ni bukan 90 degrees lah. Okay? So you need to make sure it is 90 degrees perpendicular. And then you can get the moment. Okay? So for this one, this is the point and this is the force. So this is the 90 degree. Okay? Right. Moment in 2D, two dimension. The moment of a force about a point provides a measure of the tendency for rotation, sometimes called a torque. The moment of a force, no formula. You need to remember the formula. Okay, so the moment of a force about a point or axis can be defined as a measure of the tendency of the force to cause a body to rotate about the point of axis. So point to rotate, this is Z. If you give the force of Fx, so the body will try to make a rotation. Okay, so if you give the moment, the cause action will be a rotation. See, in the 2D case, the magnitude of the moment is m moments time distance. As shown, d is the perpendicular distance. This is perpendicular distance from point O. This is point of action to the line of action. So this one. Okay. As shown, D is the perpendicular 90 degrees distance from point O to the line of action of the force. What happens if you have another forces that act like this? Okay, so when the force acting on the line of your action point, show me the distance. Show me the distance perpendicular to our point O. So this one, when the line of action acting on our point of action, okay, there is no moment for the blue one. But for the red one, we have this point. It is on this line. No touching of our point of action, and we have our point of action O with perpendicular 90 degrees. So this one is our D, and this one is our F. We have our F and we have our D. So there will be a moment. In 2D, the direction of moment is either clockwise or counterclockwise, depending on the tendency for rotation. So we decide clockwise or anti-clockwise in our answer. But from the question, if they have for the question is counterclockwise, you need to use the counterclockwise as positive. For example, moment FD and the direction is counterclockwise. Often, it is easier to determine moment by using the components of F as shown. So we have moment here. Okay. So that is our moment. And we have point O. Okay. Point O. This one is our point O, point of action. And then this is our force. So we need to break up our moment into X and Y. So we have Fx, Fx, and Fy. So for Fy, we look at for Fx, what is the moment? Okay, so for Fx is acting on this line. Fx. So it is along the line, the moment, but you need to find the distance from that point of moment. Okay, so our point of action is O. So we have this O and perpendicular to the line of action for the Fx force. Okay, so we can transfer this is the same. Fx. Okay, so our Fx, the distance is P. Okay, so that one is for Fx. Then we have our Fy. This is the line of action for Fy. And our point of action is at O. So which line is perpendicular to our point O? How do we find our distance? Just 90 degrees from the acting line. Then this is our Fy. So Fy times our A. A is the distance for our moment force of Y. Fy times A is for the direction moment for Y. Using this approach, so we have Fy times A and also Fx times B. Using this approach, note the different signs on the terms. The typical sign convention for a moment in 2D is that counterclockwise is considered positive. Okay, counterclockwise is considered positive, but you can have your clockwise as positive, depends on the question. But normally we have counterclockwise as a positive. Okay. Why do we have Fya is positive, Fxb is negative? Okay, so please have a look for our Fx. Okay, Fx. Actually, from point O, we have our distance b, and then this is the line for Fx. If you need to fix that O. Fix that O, and then fix that O, and then try to look at like your watch, okay, analog watch, counterclockwise. Okay, this one is clockwise, so counterclockwise and clockwise. For moment, counterclockwise is positive, so fix your O. You need to fix your O, and then you can find that your Fx is clockwise. Your Fx is clockwise direction. Okay, understand? And then, so Fx is clockwise. Clockwise is negative. Then, try to look at your Fy. We have Fy. Here is the line of Fy acting on the body. We have our O. Then, okay, that is perpendicular. Fix your O. You need to fix that O and try to rotate to the direction of the force. Okay, so you will get that your Fy will going to turn in counterclockwise direction. So counterclockwise direction is positive. Okay, boleh faham? Can you understand until now? Are you okay, guys? Masih di hadapan komputer? Masih di hadapan laptop? Okay, so okay, thank you for the feedback. So masih ada lagi. Okay, so that is how we determine our clockwise and anti-clockwise direction. So please make sure that you know there are two things to remember. The first one is your perpendicular, your 90 degrees line with the line action of force and our point of action, O. Okay, so that must be 90 degrees. And the second one is clockwise and counterclockwise direction. Okay. We can determine the direction of rotation by imagine, tutup mata, picture, fix your O, and then which way the force will show you, counterclockwise or clockwise direction. So imagining the body pin at O and decide which way the body would rotate because of the force. Okay, so example. We have example 3.1. So we have soalan dia. Okay, A is 400 Newton. Force is 400 Newton. Force is applied to the frame and theta is equals to 20 degree. The moment, find the moment of the force at A. Okay, force at A, ni A. Okay, the previous one we use O. Okay, moment at O. So ni moment at A. So we need to find moment at A. What is our plan? Resolve the force along X and Y axis. Determine MA using scalar analysis. This also, you need to find and use your Soka-Tua rule. Okay, so for this one, F 400, and then you can use your break here, F Y, and this one is Fx. Okay. I like to change the color. Okay, and then this is for Fx. Fx is equals to 400 sine 20. Fy is equals to 400 cos 20 degree. Okay? Boleh faham?
Misal,
yang
FX tu ni bukan 400 cos 20 degree kan? Sebab
seorang je yang sedar ke? Okay? Salah ni. Thank you. Alright. Saja je buat salah. Tengok tidur ke bangun lagi. Okay? 400 cosine 20 sama ada termenung atau dia awang-awangan ataupun masih tak faham. Di antara dua. Okay? So 400 sine 20. Okay, so we have our fx, our fy, then we need to find our distance. So distance for fx. Fx, we find our fx first. The fx is acting on this line. Okay. So from point MA, from point A, the 90 degree perpendicular, it should be this one. This is the perpendicular. It doesn't matter that way or right or left, but you need to use this one. Then you need to so that you can see the direction and the distance. Okay, so that one D is equals to ni lah D dia 2 meter. And then we have our Fy. Fy is acting along this line, along, tak kena pun MA, so kena kira. So which line is perpendicular? Okay. So this line is your Fy. So what is your distance? 3 meter. Next, if you fix A, you pin it, close your eyes. Imagine Fx is going clockwise or counterclockwise direction. Imagine Fx is going counterclockwise or clockwise direction. So fix your A, and then you can feel that Fx is going counterclockwise direction. Okay? And again, for Fy, fix that A, your Fy is moving counterclockwise direction. Okay? So this one you need to understand and to really know. You need to use your counterclockwise and clockwise direction. Okay? You need to imagine ada orang, there are students that it's easy. I know that it's counterclockwise, but there are students that how they are clockwise, how they are counterclockwise. I'm using digital now. Okay, I'm not analog person anymore. Okay, so you need to know counterclockwise and clockwise direction to get your movement. So counterclockwise normally is in positive direction. So you have your Fx moment at A. Moment at A is equals to Fx 400 cos 20 times the distance. The distance is 2 meters. And then you need to plus or minus counterclockwise 400 sine 20 times your distance 3 meters. You can get your MA. Remember to write here that your counterclockwise is positive direction. Okay, it is important to know that you know that counterclockwise is positive. Okay, so Fx. Okay, so because of the direction of Fx, it doesn't matter because you write here this is Fx. Okay, doesn't matter. But the moment is for counterclockwise is positive. Okay, how it is counterclockwise? Okay, again I try to repeat. So we have macam mana dapat counterclockwise? How we define the counterclockwise? Okay, so the first one, we have our Fx is equals to Fx here. Okay, so we have Fx and Fx is acting on this line. Sampai lah sudah. So no attach point to the A. So tak melanggar pun. And then we have our Fy. Okay, so Fy. And Fy is acting on this line. Okay, to boleh dapat we break our force into X and Y. So for X, we look at for x first. So acting on the line, which line from A is 90 degree from the acting line? So we cannot put this way. We cannot put this way. So the 90 degree perpendicular with this line should be this one. And this is 90 degree. Okay, and your fx is acting that way. Okay, so you have your fx acting on this line. This is your distance. This is A. So you put your fx here. This is your perpendicular. So fx. Actually, ada yang tanya pula nanti kan. Okay, this is your fx. Fx is acting on this line. Okay. So you pin your A. Pin. It cannot be moved. But try to move your fx. Fx. Okay. Try to move your fx. What happened? What happened if you try to move your fx? And then you will find that if you move, try to push your fx, it will move that way. Okay, so that way. Okay, that way is counterclockwise. Okay, remember your watch. Okay, your watch moving clockwise direction. This is clockwise direction. But if your watch moving the other way around, okay, this is called the counterclockwise direction. So circle going to your left is counterclockwise. Okay, then same with our Fy. Fy is acting on the line, dot line, and then from A it is 90 degree. And Fy is acting on this line. Okay, Fy. So fix your A. Pin your A. Fix. And then close your eyes. Try to push your Fy. Then you can find that Fy will move same, counterclockwise. Okay. Kena tambah distance tak? 2 plus 3. The distance is, okay, this is for your X, okay, and this is for your Y, okay. Tengok, your X direction, this is the direction. This is from point A. What is the distance from here to here? What is the distance? From here to here. It should be this one. So Fx is 2 meter. Then this one for Fx, okay? And this one is for Fy. So Fy acting here. This is your Fy. Okay? Point A to point Y. Okay? So the distance should be this one. They separate, asing. Okay? So that is for our moment. F times D is equals to moment. Okay. Okay. If a force of magnitude F can be applied in 4 different 2D configuration PQRS, select the cases resulting in the maximum and minimum torque values on the net. Okay, maximum. Let's say F is equals to 20 Newton. Okay, what is the maximum torque? Maximum and minimum. Okay, maximum and minimum. Okay, maximum and minimum. No torque at all. Okay, so, so for the maximum, it must be 90 degrees. Okay, look at the P. Okay, so for the first one, we have P. Saya nak habis dah So P acting, if we break up the P, P will acting this way and this way. Okay, this way and this way. So this force will give the torque, but not the X direction one, because it is acting on the point of action. Okay, so P, Y, yes, torque. PX, no torque, no movement. First, PX. And then we have Q. So Q just like that. So Q will give torque. Okay. Then, ada yang jawab, thank you. Q is only one. R is going to break up R. Okay, R is that way and this way. So for RY, yes, we have torque, but no RX, because RX is acting on the line of our point of action. Okay. Final one, it should be S. S, oh, ni apa ni highlighter? S is this one. So S, no torque, no movement. No movement. So the maximum is Q, the minimum is S. Q and S, D. Thank you. Good. Okay, so I will finish our class until here, and then we will continue our lecture on next Tuesday. Okay, thank you for your attention. Thank you for your time being with me. 2 hours, 1 hour and 45 minutes, and we will see on next Tuesday. But for you that yesterday I just uploaded, but I think I've given you the link. Wait. Okay, so this is for the yesterday tutorial. when it is available in WebEx, and then I need to download and upload. Maybe during this evening, I try to upload. But it depends on our internet connection and availability in the WebEx cloud storage. Okay. The link that I've given in the chat box is for the yesterday class. Okay. But for today, I missed to record the question 1. Missed to record the question number 1, the easiest way how to find our resultant force. And for you that coming late, please fill in the attendance form. That's the form that I have pasted in the chat box. Others that have fill in the attendance form, you can leave the meetings. Thank you very much and see you on Tuesday. So our class dismissed. Thank you guys. See you on Tuesday, inshallah.